Hello everyone and welcome to another Add Maths tutorial video. Now I'll be discussing SPM 2019 Add Maths Past Year Paper 2 Long Question, Example 6 or also known as question number 6. Alright, let me read the question now. Solution by scale drawing is not accepted. Diagram 3 shows the position of jetty O and kelongs K, L, R, S and T in the sea. Kelong L is situated 400 meter from jetty O and Kelong R is situated 600 meter from jetty O in the direction of OL. Kelong S is situated 300 meter from jetty O and Kelong T is situated 600 meter from Kelong S in the direction of OS. Kelongs L, K and T are situated on a straight line such that the distance of Kelong K from Kelong T is 5 times its distance from Kelong L. By using vector P to represent 100 meter in the direction of OR and vector Q to represent 150 meter in the direction of OT, expressed in terms of vector P and vector Q for vector OK and vector RK. So this is the overall question for the question 6 part A. Let me read the question 6 part B now. If Joe uses a binocular to observe Kelong R from Kelong S, determine whether Kelong R can be seen without being blocked by Kelong K or otherwise. Prove your answer mathematically. So this is the overall question 6, guys. So I hope that you will attempt this question in the future. If you could manage to solve this question, well done. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. So without further ado, let us start to discuss the solution 6 now. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay guys, let us start to discuss the question 6 solution now. Okay, when you finish read the question, okay, I'm very sure that you will feel like, oh my god, how I'm going to solve this question in the first place. Okay, well, don't worry guys. I'm going to show you the step-by-step guidelines on how you're going to solve this question. Okay, first of all, when you read this type of long question, read from start until the end in detail. If you cannot understand one time, try to read again, and from there you collect as much as information and then you interpret in the mathematical form. Okay, sounds too technical? Okay, don't worry, I'm going to explain it to you now. Okay, for the question 6A part 1, okay, the first step, what I would recommend to the student is, okay, you sketch the diagram. This is the very first step what you need to do. Okay, all those diagram you convert into the vector form. Okay, so this is the diagram which I drew for you. Okay, so from here, your step will be quite simple. So this is your point O, point L, point R. Okay, since in the question dimension is LKT is in the straight line. Okay, this is your point L, point K and point T, okay, which divide in a ratio of 1:5. So LK is to KT. So you have the ratio of 1:5. Okay, so you draw everything, you sketch everything, so you will have a rough idea on how to solve. Okay, by the time you do this, you will have an idea on how to proceed, guys. Okay, and then from there, continue to decode the information from the question. Okay, vector P is actually represent 100 meter in the direction OR. Okay, that's good. Okay, and vector Q represent 150 meter in the direction of OT. Okay, OT is from here to here. So from here to here you represent as vector Q, and from here to here, where from point O to point R, you represent as vector P. Okay, so let me show you the diagram again. So this is your diagram and this is the requirement from the question, guys. Okay, where your vector P represent 100 meter in the direction OR and vector Q represent 150 meter in the direction of OT. Okay, let us continue. So in order to attempt this type of question, so what you need to do, you need to come up with all possible type of vectors, guys. Okay, so I'm going to show you them. So Kelong L, in the question they've mentioned 400 meter from jetty O. Okay, let me pull the paper up if you can't see it. Okay, so Kelong L, since they mentioned in the question 400 meter from jetty O, so from here you can denote that vector OL is equals to 4P. Okay, why 4P? Okay, Kelong L, as you see here, is situated in the direction OR, and then you need to represent 100 meters in the direction OR, okay, as a vector P. So since it's 400 meter from jetty O, so that's why you have OL is equals to 4P. Okay, so this is for Kelong L. So let us continue. So in the question, they mentioned Kelong R is equals to 600 meters from jetty O. Okay, so from here you can know that vector OR is equals to 6P. So, okay, it's pretty straightforward. So L and R. So, okay, once you do that, just keep on continue, okay, to Kelong S. So Kelong S is actually 300 meters from jetty O. Okay, Kelong S, as you can see, is in the direction of OT. In the direction of OT, you need to represent 150 meters. Kelong S is mentioned 300 meters. So vector OS will be equals to 2Q. So I hope you understand the concept, guys, behind this. Okay, once you find the Kelong S, so then you proceed to find the remaining Kelong, which is Kelong T. So Kelong T is actually 600 meter from Kelong S. Okay, 600 meters from here. 600 meter from here, that means what will be the distance from position O. So from the position O, but first we find in terms of ST. So ST will be equals to 4Q. Okay, since for one unit you represent 150 meters, so since it's 600, so you represent as 4Q. Okay, and then we have solved in the Kelong S that since in the 300 meter from jetty O, and OST is in the same line, so from here you get OT is equals to 6Q, where in distance is actually 900 meter from point O. So I hope you understand the explanation. Okay, I know, guys, the question is pretty long, but you have to do this everything, then only you can able to solve this type of question. Okay, let me turn to the next page for the remaining working. Okay, once you have done everything, the first step, focus to form a relation among L, K, and T. Okay, once you have identified what are the diagrams of the vector, you sketch the diagram and then you label every position vectors, then only you can start to form a relation among point L, point K, and point T. Okay, so since in the question, it has mentioned that the LK and then KT is in the ratio of 1:5. So the ratio, as we can know that we can break into fraction form. So vector LK over vector KT is equals to 1/5. So we can cross multiply this. So from here, 5LK is equals to KT. So we can form this relation over here. Okay. So let us continue. So the second step, once you form this, what you need to do is you need to find the vector LT first. Okay, why vector LT? Okay, let me tell you the explanation now. Okay, vector LT is equals to vector LO plus vector OT. Okay, so you cannot just straight away find the LK and KT, guys. You need to find the overall, the length of the vector, then only you can focus on finding this. Okay, so vector LO is equals to negative 4P. Since you've already find in the question that OL is 4P, since LO in the opposite direction, it will be negative 4P. Okay, vector OT will be 6Q. So vector LO plus OT will be negative 4P plus 6Q. Okay, this will be your step 2, guys. You have already find the vector LT over here. Okay, next. Step 3. So once you find the vector LT, then only you can proceed to find the vector LK. Okay. So let us proceed to the working. So LK is equals to 1/6 of the vector LT. Okay. So if you not understand this, okay, I'm going to show you the question, the sketch diagram. Okay, as you look at the sketch diagram over here, the LK and KT is in the ratio of 1:5. Okay, so 1 plus 5 will be 6. So the length of LK will be 1/6 of the point LT, and then the length of KT will be 5/6 of the vector LT. So LT is in the ratio of 1:5, so that's why we have a relation of 1/6 over here. So I hope you understand the explanation, guys. Okay, since your LK is equals to 1/6 of the LT, so LT we have already find here is negative 4p plus 6q. So from here, you substitute here, vector LK is equals to 1/6 times with negative 4p plus with 6q. Okay, so it times in. So from here, you should get your vector LK is equals to 2/3p plus with q. Okay, this is your step 3. Okay, once you find LK, then only you can proceed to find the vector OK over here. Okay, vector OK. So to find vector OK, what you do? So vector OK can be formed equals to vector OL, you plus with vector LK. Okay. So from here, vector OL is 4p, vector LK we already find here, which is negative 2/3p plus with q. So you substitute over here. So vector OK is equals to 4p plus with negative 2/3p plus with q. So you calculate this. So from here you should get your vector OK is equals to 10/3p plus with q. Okay. So this is your answer for the question 6. A part 1. Okay, we still need to find the A part 2. Okay, for the A part 2, we need to find the vector RK. So to find the vector RK, what you do? You need to find using the vector RO plus with vector OK. So vector RO plus with vector OK, so you should get the vector RK over here. So vector RO is negative 6p. Okay, and then you plus with vector OK over here, which you have already find in the question 6A part 1 just now. So you calculate this negative 6p plus with 10/3p plus with q. So from here, you should get your vector RK is equals to negative 8/3p plus with q. Okay, so that is all for the question 6 part A, guys. Okay, let me proceed to discuss the solution for the question 6 part B now. Okay guys, let us discuss the question 6 part B now. Okay, the concept behind the question 6 part B, they ask you to identify whether the kelong S, K and R are collinear. Okay, basically what it means, if S, K, R are collinear, that means your kelong R cannot be seen, as kelong S and K are being blocked. If S, K, R are not collinear, that means your kelong R can be seen. Okay, these are the basic concept, guys, of this question. It's just that they are asking in the story form. Okay, the question are literally trying to confuse you, but you should not be confused by the question. Okay, so I hope you are clear. So these are the concept behind the question to check whether the kelong S, K, R are collinear. So to check whether they are collinear, so what we're going to do is, the first step, you need to find the vector SK. Okay, so let us continue. So how to find vector SK? So vector SK is equals to vector SO plus with vector OK. So from here, let us continue. So vector SK is equals to negative 2q. And then you plus with vector OK. Vector OK we have already find just now, which is 10/3p plus with q. So you add them together. So from here, you should get your vector XK is equals to 10/3p minus with q. Okay, this is your first step. Okay, let me proceed to the next step. So the step 2, once you have already find the vector SK, now you can proceed to find your vector KR. Okay, I hope you can get the idea behind this. Okay, so once you have identified vector KR, then only you can check whether they are collinear or not. Okay, let us continue to the step 2 now. So to find vector KR, in this case I use vector KL plus with vector LR. So vector KL in this case will be 2/3p minus with q, and then you plus with vector LR, in this case will be 2p. Okay, so you add them together. So from here you should get your answer 8/3p minus with q. Okay, you might be wondering how I get this vector LR over here. Okay, this is a good question, guys. So to find the vector LR, you actually need to use vector OR minus with vector OL. So that's how I get the vector LR over here. So vector OR is 6p, vector OL is 4p. So to find vector LR, OR you minus with OL. So 6p minus with 4p, that's how I get this 2p. And this 2p will be add with vector KL, and that's how we get the vector KR over here. I know it's a tough question, but this is the step, guys. Okay, so take it easy. So digest all the information that you have gathered. Okay, let me continue to the next step. So once you have already find the vector SK and vector KR, now you can confirm whether the point SK are collinear or not. So how are you going to do that? So we're going to form a relation between vector SK and vector KR using the coefficient lambda over here. Okay, the concept is easy. If you can form a coefficient lambda, that means point SK and KR, point SKR are collinear. If you cannot form the lambda value, that means your SKR are not collinear. So that is the concept behind this. Okay, so to find lambda, what you do? So vector xk, which is 10 over 3p minus with q, you divide with vector kr. In this case, your vector kr is 8 over 3p minus with q. Okay, now the question is, can you come up with the lambda value? Can you simplify this vector value and you factor out? Okay, the answer is no, guys. Okay, you cannot come up with the lambda value. So if you cannot come with the lambda value, so from here we can conclude that Kelong R can be seen without blocked from Kelong S and K. Since your lambda value could not be formed, S, K, R is not collinear. So this is your answer, guys, and you have already supported with this mathematical statement. So Kelong R can be seen without being blocked from Kelong S and K. So this is your final answer. Alright, that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Thank you everyone for your support, and I'll see you in the next video.